right? Little kitchen chemistry for everybody today. Yeah, the main reason why this is a problem in the Adirondack Park is the geology. So in the Adirondacks, right, the main geology, the main bedrock is granite. Granite is silicon dioxide. Here in central New York, the main bedrock is limestone. So buildings like the Hall of Languages are built out of limestone. Limestone is calcium carbonate, right? So we take our acid rain. So this is DI water. I added HCl to this to make it acidic. And then I added bromothiamyl blue, which is a pH indicator. And so the color of that indicator changes based on the pH of the solution. So under acidic conditions, that indicator is yellow, telling me I've got acid rain present. So, all right, here's my acid rain. My acid rain, I'm going to dump my acid rain on the Adirondacks with their granite. And so what's going to happen with this solution when I dump it into the Adirondacks and their granite, the granite stone from the Adirondacks? Yeah, nothing, right? Jessica, I think Jessica's our resident geologist, maybe, or our environmental scientist. And so, yeah, I dump that acid rain in, right? Nothing happens, right? It stays acidic. It's still yellow. I apologize, it doesn't come up as well, but it's still yellow, indicating I have an acidic solution. So in the Adirondacks, that acid rain falls, the acid rain falls and does not get neutralized because the granite, the silicon dioxide, and Jessica, I was going to put feldspar down there, but I just didn't want to confuse people. So I just kept it simple to silicon dioxide quartz. Right, that acid rain falls and it builds up because there's nothing there to neutralize it. All right, now here in Syracuse, where we have our limestone, right, our limestone and marble, I dump that acid rain in. Right, and it's immediately neutralized. It's immediately neutralized because calcium carbonate. Yes, I'm wearing goggles. And I also have a long sleeve shirt on. So yeah, we dump in that acid rain. The acid rain is completely neutralized. There was even some bubbling of the solution as carbon dioxide was given off, as the carbonate reacted with the acid to break down, giving us carbon dioxide gas. Yes, wearing closed-toed shoes. Don't worry. Don't try this at home, right? And I can even add more acid to this solution, right? So I'm going to add some more acid to this solution. I don't have long hair, Dominic. Right? Let me just add a bit of acid to the solution. So I'm dumping in some more acid rain. Quite a bit of acid rain, actually. Let's see if I can get this to change color, right? It's getting lighter, it's getting lighter, it's getting lighter, right? It's almost becoming yellow because I've added in more acid. I added in more acid, right? We all saw the color change. The blue has gone away, right? So it's becoming more acidic because I added in more acid rain. Oh, it's going to take a little bit while. Maybe I added in too much acid rain. Added in a little bit too much acid rain, but I've got one more trick up my sleeve. Surface area, right? Some ground up calcium carbonate. I'm going to try to get rid of it for you. I think I added in too much acid rain, trying to get the color to change. Right, so I had that. Yeah, the blue is back, right? The blue is back because that carbonate is able, right, to neutralize that acid that was added. And all I did to cheat was, right, the surface area. I've got these tiny pebbles of marble in there. I just added in some ground up calcium carbonate, right? Increase in surface area, increase the reactivity to help that transition. So the main reason why acid rain is a bigger problem in the Adirondacks than it is here is because the underlying geology, right? That calcium carbonate here, the limestone here is able to react with the acid that falls in the rain and buffering it. Exactly, the rocks, right? Whereas the granite, the silicon dioxide doesn't have that capability. And someone asked why, right? We were talking about, right? We're talking about calcium carbonate. Calcium carbonate ionizes into calcium 2 plus and carbonate CO3 2 minus, right? So why does this have the ability to buffer our solution? What about this buffers our solution? Only the best people are left-handed, Nancy. So what about this? What about this is buffering? Why does this buffer our solution? Yeah, right. We've got carbonate, right? Carbonate is the conjugate base of bicarbonate, hydrogen carbonate. Hydrogen carbonate is a weak acid, right? This is a weak acid. And the weak acid, right? Because this is a weak acid, that means the conjugate base of this carbonate, the conjugate base of a weak acid, is going to behave like a base. And so because I have calcium carbonate, I have this equilibrium between some calcium and some carbonate, right? To answer why I can change that pH, I've got to think about, where does carbonate come from? Carbonate is the conjugate base of a weak acid. Because it's the conjugate base of a weak acid, it itself, right, will behave like a base. And so it reacts with that acid rain, it neutralizes that acid rain, right? It buffers that solution. It buffers all the rain that falls here. They don't have that ability in the Adirondacks based on the geology.